Welcome to another Great Cow Basic tutorial. This is focusing on the PIC-AS capability of Great Cow Basic. So recap, Great Cow Basic's been supporting the PIC-AS XC8 toolchain for PIC-AS for about 2 years, but I've done another set of videos, this is the final part. You can download PIC-AS if you want to install it alongside your Great Cow Basic installation from SourceForge and from Microchip, of course, but the one that we've tested is up on the Microchip compilers folder. It is a standalone installation. If you want to do what I'm showing you, you have to install PIC-AS as a prerequisite. And in previous videos, I've detailed how you actually do that. Okay, so Microchip recently released this PIC-AS. It's called PIC-AS. It's a new compiler, and it replaces the decades-old MPLAB-X assembler and linker. So why we need PIC-AS support? It's good for teaching aid. It's what I'm going to do today. You can do some debugging. You get support from Microchip if you need it. In the case that where MPLAB-X doesn't support that chip, or you've got a 64-bit operating system. So if you've got a 64-bit operating system, you will need PIC-AS. So let's just take you into a demonstration, right? No, there's no mucking about. I am going to start up the MPLAB IDE, and I'm just going to start it up just to show you that is running. Okay, all right. And once that's operational, we're going to create a new project inside of GC code. So this is the GC code. This is the Great Cow Basic IDE, and I'm going to create a program from scratch, and then we're going to import that into MPLAB. Pretty simple stuff. I'm using firststart.gcb. That's a GCB source file, and I am just going to type it in by hand. Okay. I'm going to take a 16F17126, and it sort of helps me with that part because it knows I need that part. And then I'm just going to put in some simple code. Option explicit means I need to define my variables. I'm not using any variables, but it's always good practice. Okay, do loop. And all we're going to do is flash an LED and then take that do loop into MPLAB and see it work. So what I'm going to do is pulse out an LED. I'm going to use port 8.1 for 100 milliseconds, and then I'm going to wait for 100 milliseconds. That is my program, and that is good enough for what we need to do. I pressed F6 to create a hex file. It has compiled it. How do I know it's compiled it? Because it says down here, assembling program using PIC-AS. I have pre-selected that inside of Edit Programmer Preferences, Compiler tab. I have selected my assembler as PIC-AS. Okay. So I now know that I've got a source file and a hex file all produced by Great Cow Basic. But we want to import this file into MPLAB-X. And how do I do that? We need to import the .s file. So if you press function key F4, and you can see on the screen open S file, and here is the .s file that's been created by Great Cow Basic. And in here, it has got our program. It's got our loop and our setting of the LED exactly as we want. Okay, now this is compatible source. So here goes. I am just going to take a copy of that location of that file. Right-hand mouse button on the tab of the name and copy the path. Now into the mystery of MPLAB-X. I'm using version 6.05. Previous versions still work, and I'm using PIC-AS version 2.41. But here we go. New project, standalone project, next. Select the chip PIC 16F17126. Again, it offers it all up. Simulator is my tool of choice. Toolchain XC8 or PIC-AS or PIC-AS. I should take PIC-AS 2.41. Next. Type in the project name. I'm going to give it the same name as the chip. And I am going to set that as my main project because it's the only one I've got, and say finish. So I've created an empty project. I have no source files, but what I've basically said is here's a project, and it is a PIC-AS project. So I need to insert a source file. If I open up my project, source files, right hand mouse button, add an existing item, and in my cut and paste buffer, I've got that .s file, and here it is, GC Studio, Great Cloud Basic, demos, first start sample.s, select, put it in there. So I've now got a source file. I am ignoring all these errors down here because I don't know what they are. Okay, so we've now got a source file called first sample. Let me zoom in on that for us. We can see that. Now, how do I zoom in? Here we go. I'm zooming in on there. Let me just pull that up so you can see it. First sample, there it is there. If I click on it, that is the source file that has been generated by Great Cloud Basic just now. I guarantee you. Okay, and here's the date, for instance. Okay, into production, build the main project. This will just confirm to you that the project has been compiled correctly. As you can see, it has been built successfully, and that's been built successfully because we haven't changed anything. It worked in Great Cloud Basic, it will work here. Okay, now what I need to do is I'm going to go into debug main project, and you've got discrete. So I'm going, okay, discrete debugger operations build for debugging main project. It will now recompile in the debug mode. And then I'm going to select debug discrete debugger operation. For some reason, it's up. There we go. It was slow there. Launch debugger main project. You can now see it's sitting inside of a program, and it's actually inside of that .s source. It's there. So let's just add a watch in here. Let me just clear all those down because they're not needed. Delete all. I'm going to add in the latte SFR. So if I come into here, I can type in just so you can see it, or latte. There we go. And I can open that out, and this is the actual port of latte, and we're expecting this to flash or come on and off. And where it does that in the program is at this location here, BCF. So if I just put a pause there, put a break in it by selecting it and press function key F9. And where does it set it? Here, there's the BSF there. I'll just put a break there. And what I'm doing is just using the MPLAB capabilities of their own debugger and simulator. So I am currently at the first line of the .s file, which is the code that's generated by Great Cloud Basic. I can press F5 and it will run down to that BSF, and it says latte has been set. Something has changed, and that there has changed to 1. I can now run the code again, and the next time it stops after the delay, it's changed to 0. I can then run the code again, and the next time it stops, it's set it to 1. So we can see an LED. If that's the port, that's the register bit changing as per the code specified in Great Cloud Basic. Now, what you can't see in here is some of the comments, etc., etc. Let's stop the debugger. Let's put that on the right-hand side of my screen, and we're going to put GC code on the. Why has it done that? You can't see what. There we go. They're side by side now. Okay. If I come into my source program and I change that to 10 milliseconds, I change my wait to 10 milliseconds, I recompile, you will see the source code in your IDE program change, because look, it's changed here. Let me add the comments. I'm going to add the comments into the Great Cloud Basic source program. Show basic code as comments in assembly. Okay. Do that. Recompile, and it will change the source. And now we can see all our commands. Here's pulse out, and here is the wait 10 milliseconds. So if we change that to 5, I'll leave it at 10, recompile, you'll see that the source is now changing. So to rerun this, debug discrete project, build for debugging main project. Once it's completed, we should debug discrete launch. And now we're back in the program, and we can now walk the program. Now here, my previous break is no longer valid, so I just need to clear that. Clear that one, done. And here's the BSF, which is set in the register .bit, and I can walk the code. Press F7. It will go to the program start. It will call init.sys. So init.sys will set up the oscillator. It will then change the AND on the chip. It will then ensure that the comparators are turned off, and then it will set the ports to off. Then we look here, BCF. We can look at our latte and see what happens. And it's just cleared it. It will do the delay, and now it is running away quite merrily. So now it's turning it on and off in our loop that we defined. So what I've just done very simply is created a great Cal basic source program, created a project aligned to that inside of MPLAB-X, imported the file, and then I can walk it in a proper debugger provided by Microchip. So in this case, you can learn how the source code works. You can see how the source code works. You could recompile your changes to see how those work. You can debug and put debug breaks in it. You can attach it to a PIC-Kit 4, attach it to a real chip, and walk the code. So now you've got the opportunity to really debug and really experience the low-level outputs from Great Cal Basic integrated into MPLAB-X. With that, I'll call it a wrap. Enjoy.